Right, this is going to be an aluminium intensive presentation. As you all know, aluminium is the best metal on the planet, and it's the most useful metal on the planet, and it's the most sustainable metal on the planet. And don't be confused by any other imposter metals. You're probably most familiar with it in its use in drinks cans. It enables the contents to be in a drinks can, and it enables it not to leak out, and you can crush the can on your head when you finish drinking the beer. So which is very useful, but it's not really a particularly good use of aluminium. Aluminium is really good in things that move. But the most interesting thing that you need to know about aluminium is very energy intensive in its primary manufacture. And in fact, we should stop the primary manufacture of aluminium tomorrow, really. And we should use the billion tons of aluminium that we already have to make everything we want to make in that metal. It's a real fundamental change. We can almost no longer afford to keep making more aluminium from bauxite. But of course, the world doesn't see it that way. The industry is geared to keep making more and more, but it shouldn't be doing that. So there is another way of looking at aluminium. We should really see aluminium as a resource that we already have, that we've already invested all the hydro and other energy into that material, and we should just really keep reusing it. So it's a completely different mindset. And this is what I've been trying to push for the last 15 or so years with limited success, I would say, so far. And why do we need lighter weight materials to build our cars? This is the slide that people see and use very, very often, because they shouldn't really be using this slide. They should be using the red line, which is what's actually going on. Because we all think that the world is a nice place, there's all this lovely regulation, and all the OEMs are gradually giving us more and more efficient cars that use less and less fuel and produce less and less pollution. But of course, the world is nothing like that. The real line for Europe is the red line. And you've got bugger all chance of getting from there down to where we want to be here if we continue as we are. It's just a nonsense. And when anyone puts that slide up in a meeting, you should walk out immediately and say, why not work on reality? Why not work from a real fact base? Why not work on the real emissions that you're getting from cars? Why not sell cars with the real emissions? Why do we tolerate OEMs telling us that the emissions of their vehicles are what they think they would like to be rather than what they are? It's completely wrong. So, yes. But if we want to use aluminium, and we want to use it efficiently and effectively in our vehicles, it's got to be low energy and it's got to be low cost. And the only way you can combine these two features is not buying primary aluminium, whose price is up here. This is the LME price of aluminium as a function of time, and this is the scrap price of aluminium as a function of time. I've just put the price of old rolled building scrap and the price of baled end-of-life beverage cans. And you can see that the price is just about half the cost of primary aluminium. Of course, primary aluminium isn't what you pay when you want to build a car. You have to pay all the added-on costs from turning that primary aluminium into the product that you want to buy to build your car. So really, if we want to get to a realistic target for what the OEMs want to pay for their incoming aluminium sheet to build cars, it's less than the price of primary aluminium. So you haven't got a prayer of making affordable aluminium cars out of primary aluminium. So really should stop thinking about it and just think about how you would make your cars out of secondary aluminium. Could you make them out of old cans? Not really, because that will just disrupt the can market. But could you put things like old building sheet, or even better, could you put end-of-life cars, the aluminium from end-of-life cars, back into new cars? This target of $1,400 a ton for incoming materials was given to me by Mark White of Jaguar Land Rover in about 2003, 2004. He was the real key guy at Jaguar Land Rover who really catalyzed their lightweighting program and got aluminium used in their vehicles. And I told him that if he really wanted aluminium to go across their whole vehicle range and beyond into not just luxury vehicles, but into more affordable vehicles, that we had to go from making aluminium from primary onto a scrap base. And he liked that, so I could also explain to him that there's plenty of this aluminium scrap around. You can see that we're still continuing to export lots of aluminium from Europe, mainly to China and India, where it's hand sorted and reused. I mean, that's just awful. We should not tolerate that happening. We should be using our own scrap, recovering our own scrap, and turning it back into premium products. Most of the metals are bad in this regard. So I was encouraged by Jaguar Land Rover to start getting behind this whole idea of how we turn aluminium scrap back into cars. So I initiated what became known as the Recycled Aluminium Car Project, and it went through 2 iterations of proposal and getting money, and then fighting to get money, and then fighting to run the project. And very quickly we realized that Jaguar Land Rover, not only weren't thinking about what was happening at the end of life, but they weren't also thinking about what was happening to their production scrap. So when you punch aluminium components to make cars, you get about 50% scrap immediately. And you can either let that go out to a scrap dealer for $50 a ton, £50 a ton, or you can actually just reuse it as the primary metal, where it's worth the price that you were paying for aluminium in the first place. So the very first project was just to get Jaguar Land Rover to understand the value of their scrap, which was hugely important. And we also managed to shred some Jaguars, and we found that it would be very difficult to pull those back into new cars. So we then did Real Car 2, where we looked at other sources of pulling back the waste from recycling plants, and also found that was very difficult. But we now have Reality, which is the new project, where we are really looking in great detail as to how we pull back the aluminium from end-of-life vehicles. It would be quite nice if vehicles were nicely dismantled and all the parts came back nicely, but that will happen in time. It might happen quite quickly for some of the higher value cars, but it's not really going to happen for most of the cars that come to the end of life, where they go through a shredder. Because in a shredder, a car is reduced to shred in 15 seconds, and it's very hard to come up with a dismantling procedure which will compete with that. So in reality, we're trying to get the aluminium fraction back from the shredder, and we've got a very interesting group of companies. Probably the biggest thing that's happened between the earlier projects and the new project is we actually have a really good recycling company involved in the project, and that's Axion. And they are, within the UK, as far as I can see, the only company who's really interested in trying to pull high value out of the different scrap streams. So what we're trying to do is we're trying to get the shred from Axion's shredder, and then we're trying to then separate the shred initially into wrought and cast aluminium alloys, and then we're going to go further than that and try and sort the shred into the individual aluminium alloys. And if we can do that, we can do it cost effectively, we can actually use our old cars to make our new cars, which will be a huge improvement. And really the project just comes down to looking around for who has the right technology to actually do this sorting of the shred. Tomra are doing very well. They've got an X-ray transmission sensing line that looks like it'll sort wrought and cast. Steinite have got the same sort of thing. Sense to Sort have got something similar. Redwave have got a slightly different sorting and sensing. But this is really what needs to come in, and this is technology that really came from the food industry that's now coming into the metal industry for very rapidly sorting of materials. It's doing very rapid analysis, very rapid sensing, and very rapid sorting. And if this can be done efficiently and effectively at the right cost, the whole business of bringing things back at the end of life becomes entirely possible. The other thing we're working on, this was done in a European project, one of those grisly European projects where I think that the main advantage of these type of projects is getting to know people in other parts of Europe, and having a few good meals and a few good drinks around the place. It rarely does anything useful. The Innovate UK projects are far more effective at doing that. But this was a project, and most of the projects that I write always have an al in somewhere, so you can tell if I did it. And this one was rather nice because what we were doing, we were taking some of the dirtier casting alloys that we were getting from end-of-life vehicles, and we were trying to take the iron out and try to make them into much purer casting alloys. And this is based on some technology at Brunel where we take the melt and we subject it to conditions of high shear and high turbulence, and we nucleate the growing iron phases with little oxides, and these iron phases grow in the liquid and separate from the liquid, and we get a pure fraction out. So this is addressing the immediate need of improving alloys in recycling. It's also what it does in the future is if we have 2.4 million redundant aluminium engines every year, what we will be able to do is process that metal and turn those casting alloys into something that could be used effectively for other things, for new vehicles. The other thing we can do is by controlling the way we process the melt and the way we solidify the melt is we can grow alloy microstructures which are much more tolerant of impurities like iron. And so it's the approach we're presently adopting to make the whole thing more sustainable is to do proper sensing and sorting, get the scrap back in the right form, and then do processing to try and make sure that we can use those materials exactly how we want to, exactly to make the components for cars that we need, and critically to make the components we require for the next generation of electric vehicles. Right, so I'm not sure any metal can be considered green because I'm not sure, and when we're talking about materials, the first thing you should think about when you're considering material is how many tons of CO2 was made to produce the first ton. In the past, we always used to worry about how strong it was, what color it was, whatever. But now the most important thing is how many tons of CO2 were actually used in the genesis of that material. So aluminium in its primary form ranges from something like 4 tons per ton if it's blessed with hydroelectricity production and it's the most efficient smelters. But most of the smelters in China that are making most of the primary aluminium, are around 16 tons per ton, which is truly shocking. And that's because the electricity they're using to convert the aluminium is made from is coal-powered electricity generation. So in fact, aluminium in its primary form is getting less green. But I don't really think that primary metals can be considered to be green anyway. So things are going wrong. Aluminium, great, but use aluminium for things that move, not things that just hold sticky drinks. There are developments in technology which are really going to make a big difference in our ability to recycle end of life. We must get into closed loop end of life recycling. We must make dropping a can and losing it on the street a capital offence. It's simple. I mean, we're talking about deposits, but that's not really going to do enough. I think capital punishment for wasting cans is probably the answer. Yeah, and in my world, my world in metallurgy actually started in this very building in 1967. It's the first time I've been back. Probably had a lot more hair, nasty facial conditions, and I joined Imperial College in 1967 to study the wonderful world of metallurgy. And for some reason, they didn't have enough buildings, so we actually came into this lecture theatre. So this is my entry to the world of metals, and this talk is probably my exit. So, so it's a nice circular economy story. So I'm recycling myself. Yeah, this is, yeah. But the only things that are really worth working on are recycling, but not only seeing recycled materials as inferior to primary materials, but we must make our recycled materials better than the primary metals. So property improvement is important. And we also need to know how we join things to make structures without losing the properties that we put in. So that's it. Thank you for your attention.